Hey folks, how's it going? This is Mr. Murray coming to you with a Do Know activity for March 24th, 2020. Okay, in this activity, we're going to recap what we know about bearings because yesterday on the 23rd, I just had you guys investigate what are bearings, how do we write bearings, what's the notation for them, okay? So you can get familiar with them because I think it's good to have a chance to absorb that so that we know what we're doing when we actually have to use them, okay, in a problem-solving context. So what I want you to do in this do now is I want you to draw pictures for each of these bearings, okay? The first is north 40 degrees east. Okay, the second is west 30 degrees south. The third is south 120 degrees east. Okay, and for each, I want you to come up with one at least other way to write the bearing. That would give me an equivalent bearing. Okay, and so if you have not yet seen the 323 activities, I'd really recommend you do that first. But if you have, I want you to pause the video, try to solve this problem, and then when you're ready, unpause, and I'll show you how to solve. Alrighty, so here's the idea behind this. So, and I saw just other day a really awesome video from Mr. McCready really breaking this down. So when we think about north 40 degrees east, we're looking north, right? We're starting north, and then we're turning 40 degrees towards the east. Okay, so that means this is what our bearing should look like. Okay? This is what our bearing should look like. North, 40 degrees to the east. All right? And so if I was to set this up on the coordinate plane, I'd have south, I'd have east, I'd have west, right? And so another way I could write this, well, there's a couple ways. I could write it as east, because think about it, this is breaking it up into four essentially 90-degree angles. I could do east 50 degrees. I could start east, I could turn 50 degrees to the north, and I'd be on the same footing. I could do south, and I could turn 30, because that's 90. I need to get to 50, so I need to go, I need basically the supplement of 40, right? So 140 degrees to the east. Okay, a couple different ways I could do that one. Could even probably do one with the west as well. Could start to the west and turn 140 degrees towards the north. So lots of different ways you could do that. Okay, on the second one, I've got west 30 degrees to the south. Okay, so I'll set this up again. Okay, so it's again north, east, south, west. Never eat shredded wheat. All right, and so I start at the west, and I'm going to turn 30 degrees toward the south. So I should get a picture of something like that, right? I'm looking west, and then I turn 30 degrees towards the south. So if this was my ship or my airplane, this would be the bearing it would follow, right? It's 30 degrees south of west. Okay, another way you could write this is you could write this as starting at the south, I'm going to turn 60 degrees west. That would be another way to write that one, right? You start at the south, you go 60 degrees towards the west, and you're in the exact same place. Again, what I'm getting at here is essentially supplementary angles, and rather these actually be complementary angles, but here what I was getting at would be like your supplementary angles. All right, finally, south 120 east. Again, I'm going to set up my, and you don't really want to do this every time you're solving a word problem, which is what we're going to move on today, but it's good to get a sense of your bearings, if you know, no pun intended. Okay, so I'm going to start south, looking south. I'm going to turn 120 degrees to the east, and we know that this is only a 90-degree angle, so I'm going to turn this much right here, 120 degrees to the east. Okay? So another way we could write this is we could write this as north, and then I turn 60 degrees towards the east. Okay. So lots of different ways to write bearings. Where we're moving on to today is we're going to actually start using these bearings to solve problems. So maybe I'll tell you a ship is traveling along this bearing and it goes this far, and what we're going to have to figure out is how does this fit into a triangle that I can either use the law of sines, the law of cosines, or SOHCAHTOA to solve depending on the particular situation. Okay, so hopefully you were able to get these right. Again, the alternate writings, more than one answer, but the bearing itself, the diagram, only one answer to that. Okay, so please make sure you understood what we did today. Write down any questions you have and keep the good work coming. Remember, you can do it. All right, thanks so much for watching. Have a wonderful day, and don't forget to love math.